Welcome to the Trend Detection Podcast, powered by Siemens. And now your host.
Good morning, good afternoon. My name is Eric Rude, Director with Semi, and it is my honor to welcome you to Siemens webinar from Reactive to Proactive, Mastering Predictive Maintenance with AI. Semi's committed to providing a platform to bring technologies and efficiencies to our members, and I hope you will find Siemens' presentation valuable and actionable for your own operations. To begin, it is my pleasure to introduce Ryan Mischan, Global Account Manager for Semiconductor at Siemens, and our moderator today. Ryan, could you please take it from here?
Appreciate the introduction, Eric. As he mentioned, my name is Ryan Mischan. I work at Siemens in the semiconductor space, and I'm happy to host this conversation today with some of Siemens experts in the predictive maintenance and AI technologies, and just to host this conversation about what we've been seeing around semiconductor with these predictive maintenance and AI type strategies. So as the title suggests, this is really it's a hybridization of predictive maintenance, which is not such a new topic. It's a little bit more mature. A lot of companies have a predictive maintenance strategy or are leaning that way, and we'll look at what that looks like. But then also with the emergence of AI, especially in the industrial field, how to couple that to really make a more robust and impactful predictive maintenance strategy. So we're happy to discuss this with our experts and hopefully provide some additional insights to people out there in the semi industry. So just a couple of table setting statements that we've heard from. Number one, there's an automotive manufacturer that we've been working with for quite some time. And I'm just going to go ahead and read it. So we saved $45 million in labor and unplanned downtime avoidance at a single site since 2019. So cumulatively $45 million in this labor and unplanned downtime just by implementing a predictive maintenance strategy. So by working with their historical data and sensing and tending to issues before they break can really have some huge upsides for your bottom line. The next statement is really more of an industry neutral statement. So it's from a consultant that we've worked with called McKinsey Company. I think a lot of people may be familiar with them. And again, this is more industry neutral, but digital tools have dramatically reduced unplanned outages. Higher availability and a more efficient workforce have increased profitability by 4 to 10% in some organizations. So a lot of these digital tools are available. It's really how you implement them to best suit your application could yield that 4 to 10% impact on your business. So again, that's more of the industry neutral one, where that top one is really pertinent to automotive. But really there's not an industry out there that couldn't benefit from a predictive maintenance strategy, most notably the semiconductor industry, which we're talking about today. So just a quick introduction to the speakers, panelists. So I'll be moderating, sharing some kind of high-level information at the beginning. So as Eric mentioned, my name is Ryan Mischan. I'm a global account manager at Siemens, servicing the semiconductor market. Been with Siemens almost 18 years, so grew out of the automation drives business, and now I support our whole portfolio through our software portfolio. So yeah, that's me. I'll introduce Tim next.
Hello, I'm Tim Hunt. I've been with Siemens for 2.5 years now. Before that, I was with a company called Logan Aluminum. It's an aluminum rolling mill out of Russellville, Kentucky. I was there for 25 years. I retired from there, and I had the opportunity to really sink my teeth into predictive maintenance. I was able to do it in one of the departments, the finishing department. Was there for 5 years and had so much success by using all the predictive maintenance technologies that got promoted to being able to do that for the plant. And that's where I really grew a passion for predictive maintenance. And that's where I was able to build programs and in the departments and train PDM coordinators, and have just loved this journey using all the PDM tools, and then bringing on AI as being another part of this PDM tool. So, and it's a pleasure to be here with y'all.
Good morning, everybody, and thank you, Ryan. Todd Martin, just recently joined Siemens myself, but before Siemens, I worked at Nissan at their automotive production facility, and it was there that I began my predictive maintenance journey. Before that, I was heavily into automation and machine building industries. So it was there at Nissan that I began designing and implementing condition-based monitoring systems, and then taking those and bringing on predictive maintenance technologies. And we were quite successful at it. So that's brought me to Siemens to continue my career.
Awesome. Thanks, Todd. So today's agenda, what does it look like? Yeah, just maybe just more of on a personal note, a little maintenance thing I've got going on at my own property. I have a gate latch out there that I had to reinstall this morning. We have some rather inclement weather in Portland, Oregon, and yeah, I'm all of a sudden kind of wishing I had more of a proactive maintenance strategy for it. So yeah, just on a personal note. But yeah, what are we looking for? What are we looking at in terms of the agenda today? So we're going to look at some of the overarching challenges that the semiconductor industry are facing from our perspective. We work regularly with all sorts of end users out there, and yeah, to no surprise, a lot of their challenges ring true from customer to customer. So we'll kind of share what those look like. How can predictive maintenance address those challenges? Yeah, a lot of those challenges are easily addressable or have some big impacts if you implement a good solid PDM strategy. How is maintenance typically performed today? We'll talk about the classic, the old school break fix strategy, through a proactive maintenance strategy, all the way up through a predictive maintenance strategy. What is predictive maintenance, and what are some of the benefits that you could gain from implementing a strategy like this? And then I think a lot of what we're interested in today is how can this emerging AI, artificial intelligence technology really enhance those benefits that you may already be using in a predictive maintenance strategy, or how can you really accelerate that predictive maintenance that you already have going? Implementation of PDM, and then we'll wrap it up with a little summary. We'll get some time for Q&A with Tim and Todd, and we'll keep on moving. So we have a little bit of an interactive poll that we'd like to ask the audience members. And so poll number 1. So what aspects of predictive maintenance are you most curious about? Let's say number 1, is it the implementation strategy? Is it number 2, cost savings that you can realize by predictive maintenance? 3, the use of AI, the emerging technology, or something else? Okay, I'm not sure where the poll questions are. I have a chat here. Does everyone see the results?
Ryan, please check the poll section. The results are coming in. Okay, let's see.
I imagine there's some real juicy statistics out there for what we have coming in, but I'm not sure if I can see the controls here for poll showing. Audience view.
Okay.
Chat, audio, web sharing.
1 second,
Okay.
let me share the results with you.
Oh, excellent. Thank you. Doing some live sharing of the results. Okay. Let's go ahead, attendance, timer. Okay. Questions?
If you could go to post, then you should be able to see.
Okay, here we go. There we
37.
go. So to share this with the audience, about half of everyone said the use of AI. That's the number one thing that you're all here to learn about. Second, by a close margin, was the implementation strategies on how you implement PDM, and then roughly 11% said cost savings that you can realize with the predictive maintenance strategy. So we'll definitely hit heavy on the use of AI as we talk through some of these high points. Okay, thanks, Elle. Okay, so like we talked about, our teams work with semiconductor manufacturers across the board, and to no surprise, a lot of these topics should not be foreign, I would guess, to a lot of the people that are on this webinar. So if you're on this webinar, you're probably working directly with or around some of these topics anyway. So yeah, let's see how these might impact your business. So sustainability is one area that by far it's one of the key pillars behind all of our semiconductor manufacturers, kind of their company ethos. So that doesn't necessarily only apply to environmental impacts of sustainability, but that also it means sustainability of machines, the sustainability of the business itself. But certainly you can implement a predictive maintenance strategy to optimize your energy bill by learning from historical data to interact with machines in a certain way. You can really lower your energy bill. So that's one use case of predictive maintenance. Of course, by properly taking care of machines and processes, you ultimately lower your waste of raw goods and lost product. So that's inherently a sustainability topic that we see all the time. I think the next one goes without saying is maximizing your overall machine lifespan. So that's probably the most understood application of PDM. And then, of course, we'd like to help reduce the potential overall environmental impacts by driving down the waste and driving down energy consumption. This, as a whole, has a big impact on sustainability. Data usage and AI modeling is probably another one that like we talked about, we're all here for. So your companies out there are sitting on what I'm guessing is a huge stockpile of data. Okay, so you have historical data that's usable in these predictive maintenance strategies. You can use the data to help model your predictive maintenance by inputting them in a clever way. So yeah, leveraging your data to better enhance your predictive maintenance strategies. I think a lot of people on the webinar are probably well down the line of being able to connect and talk to different machines and different processes in their fab or backend facility. So that's kind of inherently critical for managing. Sorry, I have a dog that's barking a lot. It shouldn't last long. Yeah, being able to talk to these machines is critical for being able to manage them and send schedules out to them. And then, of course, implementing an AI strategy based on that historical data. That's sort of how we would enable AI is a lot of that historical data and being able to bring in other data sources and data streams to make your processes more intelligent. Digitalization is probably another more of like a company-wide strategy that a lot of companies are using to transform their business. And we see this a lot in the way that people are now starting to use digital tools to simulate different parts of their processes or machines, or figure out how different parts of their company work together. We're seeing a lot of this stuff, a lot of digital tools implemented to start to address that stuff. And digital tools are also helping us learn more about our labor optimization, or labor and how we implement or how we optimize labor in the workforce. So before, digital tools and predictive maintenance around those digital tools were really just seen as the ability to simulate and maybe optimize throughput. But lately, what we're seeing is using these digital tools, predictive maintenance included, in ways where we can optimize our labor. So one application would be the scheduling of labor to perform maintenance. Not just sending people out on a scheduled time, but actually learning about machines or processes in an intelligent enough way to then say, hey, at this date, I need to schedule this resource out to make XYZ changes. Really being much more intelligent about how you deploy your labor. And then also you can use that as a training platform as well, using the predictive maintenance platform to gain information, to train personnel, and of course inherently making the operations more safe and secure and easy to operate for your employees. So at this point, we have a question that I'd like to pose to Tim and Todd. So, yeah, question for the fellows. How is maintenance typically performed today, and what are the challenges of doing it this way?
Well, you see a lot today, and I was surprised because the world I come from, 30 years ago, we done reactive maintenance, but we moved on to from that to predictive maintenance. And I thought that's what everybody in the world was doing until I came to work for Siemens. And 2.5 years into this, being the customer success manager, there is so many folks doing reactive maintenance. They're running to failure. They're running to this thing just melts down. Then they go out there and take a crane and pull it out and put something else in. And there's a better way to do it. We don't have to do that no more. That was good back in the 80s, but we don't have to run like that no more. We can predict now, and you can predict 30 days, 60 days, 90 days. I mean, you can, depend on the line speed and the pressures and torques and all, but I mean, we can see way out in time to give you plenty of time to order the parts, get the manpower, and get everything together. You don't have to tear all this equipment up anymore, because secondary failures is our biggest cost anyway when it fails. This slide right here, I love talking through this slide because it brings you a big picture, because there might be some folks here on the call that don't understand really how PDM works, what the technologies are. You'll see this is the P to F curve, the prevention to failure, prevention being on your left. This is when your machine is starting to fail, that goes into a failure mode. Like you got a bearing that creates a spall on the, say, the outer race, and now it's going into a failure mode. That's your top left corner. Well, we can use ultrasound, or we can use lubrication, oil analysis to pick that up real early. But as it goes on, then we can use vibration to pick up that failure. And we're actually, at that point, we're picking it up with AI. And as it trends on down, and then you'll start getting the audible noise. At this point, before vibration, you can't even see these faults with the human eye. I've split these bearings open before. Hey, there is no fault. Well, it's there in the oil analysis because your iron count is spiking. But as it continues to fail, then the operators or maintenance will say, hey, I hear something. Something don't sound right on this line. Well, that's that bearing. The spall is getting bigger and bigger. And as the rolling elements roll over, it's creating an impact, which is a frequency. Then you'll bring in your thermography. Well, you'll see it then, the temperature is rising. Well, then the next point is failure, ultimate failure. This is where you melt the bearings. This is when you score the shaft, probably destroy your fan housing. So there's a better way to do it. There's a system here and that we can really make a difference. And I get to work with customers every week and see how we're making a difference with their equipment.
So Tim, so then what's the alternative then?
Well, I mean, Ryan, the alternative is, and we've been doing this for a long time. You know, reactive went from reactive to condition monitoring and condition-based maintenance. We've all added technologies to our equipment to measure key factors on that equipment: temperature, motor current, torque, you know, vibration, time, you know, time to activation, things like that. And those technologies were a big, huge improvement in, you know, predicting failures ahead of time, but not scalable because you would have to know what to set the limits that you were going to react to those conditions. That means if you got a few assets or a few pieces of equipment, you can keep up with it. But as I said, not scalable to thousands of assets on the floor. So that led to, well, what do we, you know, how do we scale and be able to monitor all our pieces of equipment in the facility, and leading into predictive maintenance and, you know, data analytics techniques and all that. And this predictive maintenance technologies, very mature. You know, I myself have used them for, you know, coming up close on 7 years, and with great success. So of course, a lot of people here are going to be familiar that yes, we have these predictive maintenance technologies. But what's the new and up and coming? What are we? And that's AI. Now imagine a lot of people think, okay, we're going to actually use the AI to look at those data signatures to predict the failures. In some cases, yes, but one of the biggest exciting things about using AI in this is the ability to AI to ingest not just those data signals and measurement values, but also your contextual data that you've been entering into your maintenance monitoring systems, you know, work histories. Oh, we've seen this on another one, and we input this because Tim said the bearing blew up. So now with the AI integrated with PDM, it is able to tap that reservoir of knowledge that us as human beings have put in and spent a lot of time, you know, accumulating. Another portion of this AI is now conversational PDM. And what is that? Is that rather than just say, you know, we saw this X thing happen on this piece of equipment, and this, and this, it now starts speaking to us in conversational tones that we've become familiar with in other, you know, conversational AI tools. So it really expands the group of people that can use predictive maintenance to maintain their equipment. Even in the advent for a long time, you still had to have your subject matter experts, you know, people who were familiar with the equipment that could say, oh yes, this predictive is pointed at something's going on here. But then it was still almost 100% the human being had to look at what it was telling you, take that data, investigate, interpret to get really to the root issue. Now with this conversational and generational AI included with it, you don't have to have that specific subject matter expert as much. I'm not saying anymore, but as much. And now you brought it out. You've maybe probably freed up one of your top experts on your equipment to probably do more value-added work.
Nice, thanks, Todd. So what would you say that some of the key value statements, the key benefits of PDM just in general would be?
Well, I know, as Tim will agree, the biggest one since PDM started, predictive analytics has started is downtime avoidance. It's on everybody's mind, and it is a big dollar amount. And it's impressive, but there's labor savings. How much time are your maintenance resources spending repairing a piece of equipment once it breaks versus how much it would have taken just to just adjust it, do some preventative maintenance on it to avoid this situation.
One of the big things, when the operator goes out there and hits the button, that line should run. They shouldn't be going through the struggles of lines tearing up, machines are down. The production folks, they're planning ahead. They know how much production we need to run this month, and that downtime is terrible. That's where we can come in with the downtime avoidance of saying, hey, you've got 60 days to change out this $200 bearing, and you can schedule that on the next available outage. You can have all the manpower, the pieces, the parts. The maintenance folks get their breaks, they get their lunch. Wait a minute, that means that they're working safer because it's not in an upset condition. Because that brings in the safety side of it, because when it's an upset condition, everybody's wanting to know how much longer is it going to be down. Now everything's a pry bar and everything's a hammer. I know, I lived that life, and PDM allowed us to get to an outage. Now you're in a safe work environment. Everything is a lot smoother, and you're going to have less issues by just getting it to an outage and being able to schedule. Hey, I just watch it happen, and I've seen it happen so many times.
Yeah, absolutely. Safety, big thing here. Another thing to consider is the loss of product or product. If you've got a piece of equipment, it may not break completely and stop operating, but it may not be producing product that's within the tolerances or the quality limits that you require, and you don't know about it for a while, and you're producing less, lower quality product. Or when we have a breakdown in one piece of equipment, if it catastrophically fails, how much damage does that do to connected equipment? Potentials there, and then you've got even more downtime repairing that.
Yeah, and your purchasing folks will love you a lot more when you can schedule and plan to have a bearing ordered in instead of hot shotted in. They hate spending that money to have stuff hot shotted in, and hey, you don't have to do that anymore. I mean, there's a better way of doing things.
Yeah, good point. So now when you pair PDM together with AI, so that's got to mean something more powerful when those two things are coupled together. So can you talk a little bit about that?
Sure. Yeah. So just a little bit earlier and all that, it lets you be more efficient, spend less time investigating and dig in there many of you on this call might be are familiar with vibration analysis. So you understand that there's a certain amount of time taken in going in there and looking at those vibration signatures to determine what the root cause of the problems may be, where to focus your efforts on. With AI, it's learned that. You have these defined industry-wide standards of what vibration looks like, and that's been inputted in there, and AI can provide that insight back. I use predictive maintenance every day. That's part of my role, and with the advent of this AI and conversational and generative AI in here, it's really sped up my and allowed me to monitor more, do it more efficiently, spend less time investigating those types of things. So some of the other things that, and as I said, yes, just it opens it up to a whole lot more people. So one of the tools that we use is, of course, a Siemens product, Senseye, and predictive maintenance. And I've used it for many, many years and have seen it from, close to its infancy to the state it's in now. And with this tool, I have been able to monitor thousands and thousands of assets and probably only spend, an hour to 2 hours a day doing it. Able to train others who weren't so much, predictive maintenance specialists into how to use a tool and doing it, and able to perform the same function. But as part of the, thing is that with this thing, you can monitor your whole your whole site infrastructure, potentially globally. It will feed back information like, what pieces of equipment that you should focus your attention on. And then once it does point you something, it gives you that generative AI information. It's a cloud-based application, so it's always evolving, getting better very quickly, and it does incorporate that AI.
Okay, so let's move on to the implementation of a PDM strategy. So what do you actually have to think about when it comes to implementing a tool like this or a processes like this? Are there any advice that you might have on pitfalls to avoid or things to absolutely take in mind when implementing?
Well, for sure, you need to know your equipment and you need to know how it breaks. So, to get to know where to focus your efforts, of course, you're probably, running FMEA analysis on your equipment, defining its failure points, what are the causes of those failures, what are the possible remedies. You need to know those things so that you know where to point and get your data for predictive maintenance. That's probably the key to having a successful. A lot of us may have data out there and it's stored, but whether it's relevant or not for a piece of equipment, you've got to make that determination. One of the things that made initial implementation of a predictive maintenance strategy is go for low-hanging fruit. And what I mean by that is you are probably already collecting a lot of data and you already have it stored in some sort of historian. You can start with that. You can get a lot of pieces of equipment and assets onboarded into this system quickly that way. And then from there, you just start adding to it. Oh, hey, we've got this piece of equipment. I don't have a data. Well, what data do I need? Well, I need vibration. Well, okay, so we'll start designing in vibration monitoring or any other technologies that might be relevant. Deploy it. It's always an evolving process with the company. You want to keep adding until you cover as much as you can. And then you still find you're tweaking and adjusting and, to get the best results possible.
So I'm sure it's not all a bed of roses here, guys. So what challenges do organizations typically have when transitioning to a predictive maintenance implementation like this?
A lot of times you run into the maturity of the workforce. A lot of the old school folks, we'll take a screwdriver and we'll put it to our ear and we'll listen to this bearing. I can tell you when it's going to fail. Yeah, but we've got predictive maintenance. We can do a vibration analysis on it and tell you it's a spall on the outer race and you've got this many days. You can't do that with a screwdriver. Well, we've evolved from there. Now those technologies have really proven themselves. Now we're bringing AI in, and it's just another useful technology. And you've got to have folks willing to learn, to learn this AI part of it. because there's still a lot of folks out there that see it as a black box. I mean, they're scared of it. They don't want nothing to do with it. They're not willing to think through it. And this AI is just, it's overwhelming because you still have a lot of folks that push only vibration. I'm going to just do everything with vibration. Well, yeah, and I love vibration. I mean, that's what I cut my teeth on 17 years ago and doing vibration. But this adds to it because with vibration, I can't see everything else to where AI brings in flows, pressure, differential pressure, current, amperage. I can get a 3D view by using AI that I never could get with using just the thermography, ultrasound, or vibration. So I love the 3D view that I'm able to get, and I'm able to teach that as I work with these customers. And once they get that picture, then they're like, oh yeah, because it's just like Todd said, you've already got the data. All these plants have got the data. They've got the motor current. They got the amperage. It don't cost you nothing at that point to stick that in there. And if a motor starts loading up, the current's going to spike. Well, that's something down the drivetrain line. We've had so much success just looking at things without you having to spend any extra money on other stuff. Now, the other stuff's good, adding the vibration sensors. We love that part of it too. But so that's kind of one of the things is you've got to have the right culture, folks that are willing to learn.
Yeah.
I do want to touch on something that that you guys said a little bit ago about where to manage the data being on-site versus off-site. So there is, I think a lot of the people on this call here, they have a lot of preference right now for on-premise data storage and implementation of this type of a maybe PDM data type strategy. Are you guys able to touch on what a cloud-based strategy versus an on-prem strategy might look like?
Well, no, the data storage requirements and the processing power for AI is quite large. So maintaining that kind of infrastructure on premise, has its challenges. So you would most likely, well, and it also requires a very specific set of experts to maintain that kind of system. Whereas the cloud base, which we're seeing most of the AI functionality resides. So there is that plus. Cloud-based is going to have faster response times for updates and upgrades and evolving technologies, algorithms. Any of those things being added will be more real-time added in there. Where on-premise, you're going to have to go through the update schedules and keep that, and then
That's a good point.
Security, we're all concerned about security, but all the ones that I've dealt with, cloud-based predictive maintenance is they're their own little world. Even with the AI, they're not sharing resources outside that. They're protected, and nothing goes in without the proper credentials. The AI does not send any of its data out to these other AI systems out there in the cloud. It is all local for that particular application.
Yeah, good point. And maybe a moment about safety and security. I guess you just talked on security there, right?
Yeah, of course, I'm not a cybersecurity expert, so I can't speak too much, but it uses all the industry standard technologies, TLS 1.2, data encryption, cyber testing, and the one that we use, Senseye with Siemens and all that, has been supports single sign-on, been audited by many different companies, and has a very high app security rating.
Awesome. Maybe a second, because you guys have so much experience directly implementing these PDM type strategies. Could you talk a little bit more about your specific use case?
Sure. And this particular slide is actually one that I was involved with. Global automotive manufacturer. One of the first site to use the Senseye product was in Europe and the UK. I came from one of the US sites, and I worked in the body shop, where all the body parts are welded together. Over 1,300 welding robots in there. Welding robots were the primary source of downtime there. It's just they're under heavy loads and they wear out. We'd had condition-based monitoring systems on them for many, many years, and we knew that we could see these failures oncoming with the data, the torque data. But before predictive maintenance, the only way to do it is you had to look at a torque graph, and that could take anywhere from 15 to 20 minutes or longer to do. So you can imagine, multiply that by 1,300 robots, the amount of time taken to it. And even if we threw everybody in the maintenance department in that shop in there, you still could not return around to a specific robot to catch it potentially in time. So we knew there that we had to have some sort of predictive maintenance. So we contacted Senseye, as the other our UK plant was using, and began a proof of concept with them, plus a few other offerings at the time. And we implemented, once through the proof of concept and testing that we did to each one of them, we chose the Senseye product. And at that point we onboarded 2,000 robots and their weld guns, and then began adding more and more and more over the years. And that's where, since with all the additional assets onboarded, we had that $45 million savings. We were actually able to justify the cost of the system in labor savings alone, not even taking downtime into consideration.
Nice. So, although this is an automotive application, I mean, we could certainly craft strategies like this for the subfab in a semiconductor facility. Also relate this to areas inside the clean room. So there's lots and lots of ways that you could apply this type of a strategy to to the motors in an air handling unit, or more of the sophisticated tooling inside the clean room. So there is adaptability of these predictive maintenance type strategies for different various areas of a semi facility. I did want to ask another question to the group. I know that we kind of touched on this a second ago, about some of the challenges that organizations have, maybe more culturally, about adopting a predictive maintenance strategy. So Tim, could you elaborate maybe a little bit more about that on the cultural side of things of predictive maintenance transformations?
Sure. We've seen the greatest success come at the plants when they have what's called a plant champion. When there's somebody there on that site that owns it, and that's who I get to work with, and Todd works with those folks, and those, if we can get a plant champion, hey, this thing will move forward and we will have true success, because those individuals are what say they catch a fan that's a dirty fan blade, and we've watched it. The AI triggered, it created a case, and we'll actually go in and create a success case slide for that. The plant champion will take it and show it to his boss, which will in turn end up going up the food chain, and hey, this is what winning looks like. They saved us this much money. So a plant champion, plants that don't have a good solid champion, boy, we've struggled with those plants, because if it's somebody that just don't care, not willing to learn, but it's hard to get any traction. Even though we're selling the story, we're showing it, but so a plant champion is priceless. Another part of it is, as far as the cultural side of it, is we really push to get these teams being data-driven decision making. That is so important. And here's an example I can give is one of the steel mills I was working with. They had a vibration jump on their motor and pump combination. And he said typically we would go out there, we would change out the motor. If they didn't fix it, we'd change the pump out. But he said we had just put the differential pressure off of the heat exchanger plates that this motor pump feeds through. We just put that on Senseye. And so we looked at that and we saw the trend, and it actually had generated a case telling us, hey, the pressure's going up, which means these heat exchanger plates are getting stopped up. He said in the past we would have started changing pieces and parts out. He said once we saw that, we knew all we had to do was clean the heat exchanger plates. Once they cleaned those, changed them, the vibration went down on the motor and pumps. So that tells you, let the data drive you to make decisions. And through that, they've been able to do PM optimization, because now they've got it set up to where this thing, it will generate a case whenever it's these filters are starting to get stopped up. So that's huge. They're not changing them out on a time basis anymore. They're changing them out when the data says the filters are stopped up. So those are a couple examples.
So yeah, before we get to the Q&A, we've got a couple of questions going in here, but we did want to just kind of wrap this up from a presentation standpoint. We do have a couple of questions though. But I mean, as we heard today, predictive maintenance is a really great way to improve lots of things: improve safety, improve your overall throughput, your machine uptime, product quality. You can train workforce. It has so many upsides to predictive maintenance, which has been around for a while now. But really, it's taking AI, interfacing with different AI tools to enhance your predictive maintenance strategies, taking also safety and security into mind when we interface with the AI engines like that, as we kind of looked at. And then, yeah, you should look to partner with a company that can look at a PDM strategy across the whole company. So how do you partner with the right company? Siemens we would hope that you would consider Siemens as one of these companies with the ability to have to provide end-to-end solutions from chip design all the way to the final integration of the sensor at the factory level, and then using predictive maintenance platform to tie it all together and make sure that your stuff, is maintained properly. So, with that, we do have a really pretty poignant question here. Tim and Todd, could you give an example of predictive maintenance and how conversational PDM might work? So you mentioned that conversational PDM. Could you explain what that would look like?
I just got to see this just actually this week, and it's happening more and more. The conversational part is, say you get a case triggered, a fan is out of balance, and they go in and they balance the fan, the amplitudes drop back down, life is good. But then they go, right before they close out a case, they'll enter what's called a work event. And that gives all the details. Hey, we watched this trend go up. We realized that it was out of balance. We went in and we cleaned the fan blades, and now that fixed it. So they type that in. Well, this week, there was an instance where the co-pilot actually, there was a case generated and co-pilot said, you need to go out and clean your fan blade. But all the details was in it. The gentleman that actually entered that information in months ago, because it had gotten dirty before, he said, that's my writing. That's how I write. I'm the one that put that in. He was so excited because it actually learns from the information you're putting in. And so, and I keep seeing that at different customers of, hey, I put that in there last year. I put that, and so they're getting excited about this because the AI is saying, hey, and the co-pilot's going in and looking at all this, and it's making decisions like that and telling them, go out there and look at this. And so that's not just an example that I've seen recently.
It's great. Yeah, the AI learning from input from some of the colleagues doing the maintenance that's an awesome application of AI.
Hey, Ryan.
Yep.
Let me add to that just a little bit, because that information that the individual put in, hey, in 5 years, this guy's going to be retired out. There's going to be new people come in that's not going to know what this looks like. And so this is a knowledge platform that you can go in and save this information from a skilled labor. The folks, before they retire out, they've got a place to put this information in. Hey, we align this motor, and you got to watch for the soft foot on this foot. I mean, you can put in all the details you want. So that's another powerful is knowledge, is capturing that knowledge.
That's another great point, Tim. I mean, yeah, we're talking about almost infinite databases out there where the continuity of knowledge, more so than what we can keep or upkeep as our own written records. That's an awesome application of AI there. We had another cool question come in, and maybe you guys can answer this. So what impact to the overall equipment effectiveness has been seen due to the application of AI for PDM? So we're looking for like an impact to the OEE by implementing AI in PDM.
Well, when we know that PDM has improved OEE, a lot over time, and then just anything that makes that PDM more effective is also going to make your OEE better. You'll get these repairs done quicker because we may tell you something's going on with the AI. It makes you can find the root cause problem quicker. Maybe you have a single day of downtime, for maintenance, 1 weekend, and you got a problem going on, but you cannot find it that way. So now you got to wait a whole another week, before you can work on it again. AI is just going to compress that investigation repair cycle even smaller, get it done quicker, reducing the potential for those breakdowns to happen before you find the root cause problem.
Yeah, good call. We have another question that came in into the chat. So it's about building up the AI-driven insights from the data that's coming from the equipment. Are these data insights, these data inputs, supervised or unsupervised models? And I think we talked about this, we showed a little bit about this with the security part. But again, this is what's the process to build up the AI-driven insights from the data that's coming from the equipment? Is that supervised or unsupervised?
I don't understand the question between supervised and unsupervised. Is that it's supervised in the point of that it's localized for your facility, your instance of this application. Yeah. Of course, talking about what can be input in there, there's two ways that this can, be done. One, you're manually entering it, as Tim said, work events, or you manually enter in other means in there through notes, results of the incidents. There's also potential where, you can provide exports out of your CMMS systems, where probably majority of your historical contextual information in regards is residing. So it can take that. So you would export that, run it through an import model to put it in the appropriate areas, in the knowledge areas of the system, and then it becomes part of it. hopefully that answers the question.
Yeah. Yeah, I think we're going in the right direction. I mean, obviously there should be the watchdog of security kind of governing the channels. But yeah, we certainly don't want just any any input going into the AI models. Okay, there's another question that came in. Have you applied condition monitoring data with process yield to provide further tuning and financial benefit?
That's a question that's been asked a lot in the past, and my previous positions and all that, using predictive maintenance, and the machine AI and machine learning required to do that is really outside of my scope on there. It's been looked at, but since the tool that I use is its focus is predictive maintenance, I have not used that for process adjustments.
I've been able to, well, one thing that I've been able to do in the past was use the AI, and taking the vibration and process data and the like alloy. What is the alloy? Aluminum alloy, because the machines will run different on different alloys, because some of them are harder, some are softer, and you can actually let the AI run, and you can like this alloy runs different than this one. You'll have more vibration. The sheet will chatter more at this speed, so we can't run at this speed, right? So we've been able to do that, and that's pretty exciting to see, is by bringing in all the process information with it. And when you overlay that, it'll tell a story that that it's just unbelievable. You're actually getting such a better view of what this machine is doing from the start to the finish.
There's another, maybe one more interesting one that came in, guys. And this is about the data coming in, if it's insufficient or not. So what if the data we have is not sufficient? So the historical data, or if the equipment is old and doesn't have sensors and logs. Are there any AI models that we can look at? Now, I think this kind of goes into the bottoms up learning versus top down. I know that the portfolio or the platform that we work with at Siemens is more of a machine learning, and then have the predictive maintenance software kind of react on it. The question is, do we have like a top down approach that we can recommend a model from the top and then push that down to the predictive maintenance platform?
Can't answer that question myself. I mean, as far as old equipment and all that, it really depends on the equipment that you got. If it's a relay machine, we're probably not going to get anywhere with that. But if it's PLC controlled and it's a cycling piece of equipment, the things they use many times is use the PLC to measure a time of flight for an operation, and then use that measured value as a predictive maintenance or a condition on there. If it takes too long, maybe there's friction included, load increases and all that, and if that's occurring over time, by transmitting that data, you'll see that increase in time, and that has been successful in the past, at least for me.
Yeah.
Okay, so I think we're kind of running up against the top of the hour here. Yeah, so we thank you guys. Thanks everyone out there in the audience for joining. If you want to, please scan these two QR codes if you'd like to have some follow-up about any other consultation around predictive maintenance, AI topics. If you want to have a conversation with us offline, or see a demo of this AI PDM collaboration hybridization in work. So again, I've been Ryan, and thank you to Tim and Todd for your expertise today. And yeah, we hope that you found this helpful, and maybe we'll talk to you all sometime soon.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.